This is Honors Pre-Calculus Final Exam Review for 2013. We're looking at numbers 37, 38, and 39. And I'm going to do number 37, and 38 and 39 are not significantly different from that, so you can do those the same way. So we'll start with number 37. So the important thing here is it says that it's a right triangle. So since we know it's a right triangle, we can think about sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in other words, you can think about your right triangle ratios for trigonometry. So we have A equals 3.2, B equals 1.5, C equals 90 degrees. Anytime somebody tells you to solve a triangle, they're asking you to find all 6 parts of it, all 3 angles and all 3 sides. So I usually start a problem like that by making a list of the 3 sides and the 3 angles. So side A, B, C, we typically use small letters for sides, and capital A, B, and C, we typically use capital letters for angles. So there are different systems for that, but most commonly we're going to use small letters for sides, large letters, capital letters for angles. Now let's fill in our given information. So our given information is that side A is equal to 3.2 centimeters, side B is equal to 1.5 centimeters, and angle C is the 90-degree angle. So I'm going to start by drawing the triangle. So I'll draw, let's see, I've got a A and a B that are 3.2 and 1.5. So let's try to draw we'll try to draw them at least roughly proportional. One thing that I would keep in mind is that 3.2 is a little more than twice 1.5. So I want to make my A side about half as long as my B side. And then my C is my hypotenuse. So the letter C also by convention always stands for the hypotenuse. In this case we certainly know it's a hypotenuse because side C is across from angle C. Angle C is the 90-degree angle, and hypotenuse is always the side across from the 90-degree angle. So now we've got our triangle labeled correctly. We know this is side C. Since I put my A down here, we could have turned this triangle, but I put the A down here. That means that angle A must be across from it. This is side A, so angle A must be across from side A. That's a naming convention. And then 1.5 is our side B. That means angle B must be across from that. So now I've got my triangle labeled correctly, which will be very helpful to me. Now I need to look at the information I've got. What I would like to have is angle A or angle B, because then I could use one of my trigonometric ratios to find one of the sides. But in this case I have 2 sides already. So what I should really focus on, since I have 2 sides already, in a right triangle, anytime you have 2 sides, you should immediately go to Pythagoras' theorem for the 3rd side. So because this is a right triangle, that really changes everything. It means that we can use Pythagoras' theorem. It means we can use the trigonometric ratios. We're not going to use law of cosines or law of sines on a right triangle. You can, by the way, use law of sines and law of cosines on a right triangle, but it's very inefficient. So it's much more efficient to use Pythagoras' theorem and the trigonometric ratios because it's a right triangle, so we can. All right, so we're going to find C by saying A squared plus B squared equals C squared. Our A is 3.2, so that's 3.2 centimeters squared plus our 1.5 centimeters squared equals C squared. Now we can keep these units in, but sometimes that seems to me like we're getting a little carried away with the units. So I'm just going to go ahead and drop the units here and put them back in at the end. Just don't tell your physics teacher that I did that because they don't like that. So we're going to go 3.2 and we're going to square that. So we want to go 3.2 squared, and that gives me 10.24. So 3.2 squared is 10.24. And I'm just going to clear this calculator a little bit. So we're going to delete everything. And then we're going to say 1.5 squared. Well, I know 1.5 squared. You know 1.5 squared, right? It's 2.25. Everybody knows that. 1.5 squared is 2.25, so that's C squared. Now we're going to add these together. You can go to your calculator for that, but it's pretty obvious that it's 12.49, isn't it? Equals C squared. Now don't forget the all-important next step, which is I'm going to take the square root of both sides. Many people forget that step at the end of Pythagoras' theorem. We're going to take square root of both sides. Also, by the way, always remember in an equation, if we take the square root of both sides, we're going to get a plus or minus over here. We get to ignore the plus or minus because C is a distance, and distance cannot be negative. But don't take it for granted that we're always just going to put a positive number here. It's really plus or minus. We're deliberately ignoring the negative because a distance can't be negative. So now we have to do square root of 12.49. So we're going to go square root of 12.49. And we get 3.534119. Let's just call it 3.53, be consistent with, well, to be consistent with these, we should call it 3.5. Let's call it 3.53 for the purpose of our own calculation, because if we round in the problem, then our errors will compound upon themselves. But for the sake of writing our answer, let's say the C is 3.5 centimeters. That way we're giving our answer to the same degree of accuracy that our given information was, which is a nice thing to do. All right, now I need to find angle A and angle B, and this is a problem because if I want to find the angles of a triangle, I know they all add to 180, but I only have one of them, so I can't find the other two. So what I need to do is now I can use my trigonometric ratios to find one or the other of these angles, and it does not matter which one I do first. So let's start with angle A. Well, what I know about angle A is, well, I know all the other sides of the triangle. In fact, I have found out now that this is equal to 3.5. So about angle A, I can either say that I know what the sine of angle A is because it's opposite over hypotenuse. I know what the cosine of angle A is because it's adjacent over hypotenuse. And I know what the tangent of angle A is because it's opposite over adjacent. I can use any of those three, but of the three, the one I prefer is tangent because I would rather not use this value that I calculated, because if I made a mistake calculating this value, then I'm going to get angle A wrong. So what I would rather do is use the given information whenever possible. So the given information is opposite and adjacent, so I'm going to start by saying that the tangent of angle A is equal to opposite over adjacent. And I'll start by writing that. And you do have to have these trigonometric ratios memorized. You need to know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Whether you use a mnemonic like SOHCAHTOA is up to you, but you need to know those ratios. Now I'm going to plug in my known values. So my opposite is, the opposite is 3.2, so we'll put in 3.2. And our adjacent is 1.5, so I'm going to put 1.5. And I've dropped the units again. Again, please don't tell your physics teacher that I did that. He doesn't have to know. Then I can work out what these numbers are. One thing I can do is divide this out and find out what this is and then do the inverse tangent. But sometimes what I like to do is save all the calculations for one step. So I'm going to bring my tangent to the other side as an inverse tangent and just leave this as 3.2 over 1.5. And now I'll put into my calculator the inverse tangent of 3.2 over 1.5. I'll notice that my given information was in degrees, therefore I want to give my angle A and angle B in degrees. This could have been in radians, and then I could give these in radians. But I want to notice that it was in degrees, therefore I must check to make sure my calculator is in degrees. Throughout this exam, you're going to need to be thinking about, am I in degrees or am I in radians? Look at the problem. The problem is in degrees, so my calculator should be in degrees. It says a little DEG right there, so I know it's in degrees. If I have the TI, I have to go into the mode and check to make sure that it's in degrees. Well, my calculator's in degrees, so I can proceed to do the, let's see, the inverse tangent of 3.2 over 1.5. So we're going to do inverse tangent of, and I need to put parentheses here, 3.2 divided by 1.5. 3.2 divided by 1.5. I need to close those parentheses. I need to hit enter, and I get 64.88. So 64.88 degrees is my result for angle A, 64.88 degrees. And one thing that is beneficial about having drawn this triangle at least roughly proportionally is I can look at this angle and say, does this look like a 64-degree angle? Well, sure, this looks like this could be a 30, 60, 90 triangle approximately, and maybe it's a little bit more than 60 degrees, maybe it's a little bit less, but I know it's more than 45 degrees, certainly. So I can fill in that I now know that angle A is 64.88 degrees. I want to look to see if the directions tell me anything about rounding. So let's see. It says solve the right triangle, but it doesn't say anything about rounding. So that means that it's up to me. It's my own judgment what I'm going to round to. So what I'm going to do is I'm going to use take the cue that their given information was given to 1 decimal place. And I'm going to go with that, and I'm going to call this angle A 64.9 degrees. Some of you guys who are following the method of significant figures might say, oh, this is 2 significant figures, so let's call this 65 degrees. But that's all a matter of judgment unless you're specifically told to use some method. So we can use whatever method we want, use our judgment. Now we need to find the third angle. Anytime in a triangle we have 2 angles and we want the third angle, we don't want to work too hard to get this third angle. We want to just go to the fact that the sum of the angles in a triangle are 180 degrees. And if we want, we could rewrite this formula and say B is equal to 180 degrees minus A plus C. And that means that it's 180 degrees minus 64.9 degrees plus 90 degrees, and I can now work this out on my calculator. Of course, some people just add these 2 angles and subtract from 180, so that's really all you have to do. I'm being nice and writing out the algebra. That's one way to write out the algebra. So let's see, 90 plus 64.9 I can do in my head, that's 154.9. So we'll just do 180 minus 154.9, and that gives me 25.1. So I'm going to say that my angle B is 25.1 degrees. I'll look at my angle B and see does it look like it could plausibly be 25.1 degrees. If I hadn't drawn the triangle proportionally, it wouldn't make sense to do that. But since I drew it roughly proportionally, I'm going to say that 25.1 degrees looks pretty reasonable for that answer, so I'm going to put 25.1 degrees here. Now in terms of my answer to the question, my question was solve the right triangle. And when we see solve the right triangle, what we want to do is make sure that we have listed 3 sides and 3 angles, regardless of what their given information is. So 3 of these things were given. The other 3 are what we filled in. We need to see that there are 6 pieces of information and our information is well presented. So that's number 37. Number 38 and number 39 are done in a very similar way, but I think in number 38 we're given an angle and a side. So I think we'll do number 38 as well. And then 39 will go just like 38.